Thanks so much for taking time out of your day to join us. Like Tom says, we're happy to say we are back by popular demand. There's a few people who missed our presentation about a month ago, so we're excited to share some new case studies that have just come up in the last 3 weeks with some of our clients. Pretty impactful stuff. This will be about 35 minutes to 45 minutes of presentation. We really want to dive into the technology, make this a useful half hour to an hour for you. But then after that, we want to open up the floor to discussion because we're looking through the list of attendees, and people are coming from so many different industries, so many different areas where we see an application for this technology. So we really do want to foster a discussion at the end of this. So once again, thank you. And I'll start off with introducing Quantify. So Quantify is a company that has been embracing industrial IoT. Broad strokes, what we are is an integrator of industrial IoT. So we provide unprecedented real-time visibility to your manufacturing facility. And we're able to install that uninvasively on most of your equipment, a lot of your utility streams, so you can get an unprecedented view of your processes, utility use, which fuels your ESG and profitability goals. Once that equipment is installed, we see firsthand exactly how this plays out, and we see it immediately makes the company much more connected. Communication happens much more rapidly when everyone's working off the same data set and dashboard. We see that company become much more competitive and obviously much more profitable. I do need to update this slide because in the last 2 years, the other thing we've seen, which was somewhat unexpected, and I know is a great need in the industry now, is employee engagement. So once you have this data in real time, it really does change the way your facility and company operates, and it re-engages people on both ends of the spectrum. So I've worked personally with co-op students, engineering co-op students at facilities, as well as, some older maintenance managers who've been in the game for 30, 40 years. They've seen it all, and they're kind of looking at the door on the way out. Once we put this tool in front of them, and they can adjust the set point on an air compressor or manipulate a boiler and see that data trend change in the moment and see the impact they have, you can see it really reignites people and they get really engaged again with their job. And that's really the exciting point for us. So I'm going to share all that stuff with how we do this work, the technology we use, but most importantly, the last part of this presentation after Tom shows a live dashboard tour is to show you some case studies that have impacted companies and that we've been working with. So once you get past that equipment room door, you're going to have a boiler, air compressor, cooling tower, pumps, conveyors, what have you in a manufacturing facility. It doesn't really matter what they're producing outside of that equipment room. So as you can see here with our client spread, we're working in the auto industry, petrochemicals, food and beverage, you name it. If you have an area that you need visibility on, or if you have specific ESG goals, we've seen that we can make that happen for your team, no matter what you're producing. So industrial wide, we provide that support. The other thing we do is team up with companies like Enbridge, different municipalities, government, federal government, provincial government, because they provide funding and support for a lot of this work. So we want to be an avenue for you guys to access that funding to engage with these projects. So just to kind of give you a lay of the land, this is what we typically see in Canadian manufacturing facilities. You've got your boilers running, large electrical users, all in an equipment room. This is what we can integrate into. So Canadian manufacturing is quite analog and outdated. What we've been able to do is integrate our hardware systems into that existing structure so that you get visibility on what you're currently using and what you currently own in that facility. This image here is actually our last iteration of our base station. We've increased the capabilities of this significantly. It's quite a bit more powerful now, but generally that's where it sits, and it's going to be communicating with all the sensors throughout your facility. So this is the hardware side. This is the ecosystem that we would develop at your facility. At the top there is that dashboard, or sorry, base station edge computer. And below that, it's communicating with all of the sensors distributed throughout your facility. So we've given a few examples here, some of the heavy hitters where we see some really quick ROIs on, because right now there is no visibility on those. So water mains are a really good one to start. Then go, nailing down into more granular systems like a boiler. and especially air compressors. If you own and operate an air compressor at your facility, obviously no guarantees, but every single air compressor we've engaged with and put sensors on, we see paybacks of 6 to 8 months. It's quite rapid. They're large machines that use a lot of electricity. And we know that once we can start seeing that machine operation minute by minute, we can pull out some pretty quick savings on that system. So this is the ecosystem. Most of them are wireless and non-invasive. They're constantly sending 900 megahertz radio waves back to that one base station. And now you're not having to run wires throughout your facility to get that visibility. So the deployment is quite rapid. From that edge computer then takes that data, processes it a slight amount, sends it up to the cloud on our own separate LTE system. The best conversations we have with teams, they bring in their IT specialist. They naturally have their backup because they see the sort of work we're doing. And the first thing we say is, look, we're not going to touch your Wi-Fi. We're not going to touch your system at all. We're entirely independent. We're backed up by battery systems. So they say, great, you don't involve me, and they leave the room. So that's typically how it goes down with the IT system, and that we're completely independent. Once that data is then processed and sent to the cloud, we then have our software system that takes that data and presents it in very meaningful and impactful ways. But more importantly, it presents it in ways that's very easy to read. We have to provide data that can be consumed by a production person on the floor that might be English as a second language or a recent high school grad. They want to see exactly how it's working in very easy language. And on the same side, if you flip the script over to the CEO, they want all the data immediately within a 2 to 3 minute package. How is this machine operating? How is this line running? I want the data quick and easy. And Tom's going to show you on our dashboard just how we're able to do that. So the benefits of industrial IoT, we're obviously the biggest champions of this, but we see it really having an impact with resource utilization. So you're going to have to pay those overhead bills of natural gas, electricity, and water. They're at such a large scale in manufacturing facilities that even if we shave 5 or 10% off your annual spend, it's going to pay for the whole project. And that's very doable. Benchmarking, how was I performing last year versus this year? If we do a ratio of, well, we've produced this many tons or kilograms of product, what's the ratio of water, electricity, gas we're using? We're actually engaged with a brewery now, and what they want to see is they're doing co-packing. So they truly want to see what's the cost of this co-pack product versus our own. And we can start doing KPIs on that so you get real benchmarking, real value of that cost. Predictive maintenance is another really exciting field. If you have trending data, excuse me, and you can see your vibration increase on a particular machine, you can react to it right away. Right now, a lot of the industry is working on preventative maintenance. So it's an hour or time-based. At 200 hours, we'll change that belt. At 300 hours, we'll change that air filter. Well, we've seen that within that 200-hour time lapse, something can happen catastrophically, and now you have a machine that fails in the middle of a production shift. So let's get ahead of that with real-time data and fix it on a Sunday afternoon when it's not needed. All that plays into efficient production. I've talked about the behavioral changes, really exciting there. And then management models. This is the data that people need in real time to make these decisions. We go into a lot of clients and we see them hemorrhaging a lot of utilities. We see them having zero visibility, using analog systems. Everyone naturally is excited about the the AI world. It is very powerful. We use it as our own company to produce a lot of products. And it does have an incredible strength to make your company and team more productive. But the reality is it needs digital data to work. You need to feed it that food. If you have analog data, and I'll show you in a couple slides here, I'll jump ahead. This is typically how we see how plants are used. You have an analog meter, writing that down with pen, zero trending, zero insights. You need to make digital data in order AI to work. So I fully encourage every plant to get on AI and use this new tool, but you need to give it the right food in order to do that sort of work. So that's where we come in. We see in plants, there's very little visibility. There's limited internal capacity to do this sort of work. Industrial IoT is a new market, so we want to provide that capacity to your team. As I say, we're integrators of hardware and software and give you a turnkey package. That's what we're going to bring to your team. And then beyond that, it's a lack of expertise, not just in that field, but also how do you use this data to find opportunities and implement those so that your plant is truly more efficient And that's another expertise we bring to the table. I've spent a bit of time now talking about the hardware and software and integrating that and getting it working. But to be honest, that's only half of our projects, and it's kind of a means to an end. The rubber really hits the road when we start looking at that data with your team and we apply our over 20 years of experience in manufacturing and say, look, the data here that we're now collecting is clearly showing that there's an opportunity with either this utility stream or this machine. Let's act on that and implement it. So back to this screen, we are seeing these analog systems pervasive throughout Canadian manufacturing. Some of these are Fortune 500 companies, and behind these particular meters are million-dollar assets consuming hundreds of thousands of dollars of utilities every year. And this is the visibility they have on it. So this is, I'd almost argue saying it's 19th century technology. The time has come where we can now integrate this stuff non-invasively and get your team up to speed and seeing what's actually happening at your plant. The future of industrial IoT is really exciting, and actually this is a really good time to come into the fold. As you can see, 2019 to 2025, predicting a massive growth pattern. But what's more important, especially to the people on this call today, it's really taking off in the manufacturing industry and facilities, because as we can see, we don't have that visibility, but the time has come that we now have that visibility. So that's kind of the overall approach that Quantify does with our clients. I'm going to pass it back over to Tom. He's going to share with you our live dashboard, and that's going to nicely blend into some very specific case studies that we've done over the past few years. So with that, I'll stop and hand it back to you, Tom.
Thanks, Dave. I hope everyone can see me, hear me, and see my dashboard here.
Fantastic. Yeah, looks good on this end.
Fantastic. Thanks. Okay, so welcome everyone to our IoT dashboard. Very excited to showcase this fully customizable, versatile, and modern approach to data collection and visualization, both for real time, but also historical insights into your operations. So the first thing you'll notice is this is a browser-based dashboard, which means it pretty much works on all operating systems and all modern browsers, and it's mobile friendly. So it's perfect for people working remotely or on the go. If you're a manager, maybe you're an engineering manager and you're away on a conference, you're homesick, you still want to understand what's going on with your equipment, with your facility, you can do that anywhere, anytime, very easy. So for the next 15 minutes, I'm going to spend some time showcasing some of our main features. There's a lot to cover and I'll barely scratch the surface, but we're going to touch on things like the data visualization side, doing some statistics, alerts, and automated reports. You'll note that on this specific dashboard, we're working with open source weather data just from a, obviously client privacy kind of angle, but this is all demo data, but I will show you one of our active kind of client slides at the end. So first and foremost, our job, like Dave mentioned, is to work with our clients to choose the correct hardware that will work for their purposes. We look at things like cost, accessibility, location, whether it can be battery powered or needs actual power, the accuracy, all those things. That's up to us to work with the client on the proposal stage and propose a full system or a starter package to kind of get going. Then the next thing is for us to obviously customize the edge computer, install it, and integrate these sensors with the back end of our dashboard and get that data streaming in real time. And we can take that from our sensors, but I know there's been questions about this before. We can also pull in data via an API like we are doing with this weather data. So you might have an existing database. You might have another sensor that's already kind of installed somewhere. If it has an API, it's very likely we can pull that in and show that on our dashboard, because ultimately we want everything on one dashboard. There's nothing worse than going with kind of piecemeal solutions where you have a water sensor dashboard, then you have to log into another company and have a natural gas sensor dashboard. The point of this is to have all the data kind of playing and displayed nicely together. So a dashboard is basically like a homepage, right? It's like a website. And so most of our clients start with one, high level overview dashboard that they just kind of scroll down indefinitely, and we can kind of add and customize the stuff on there, but also we can build additional dashboards to get very detailed and granular data insights. So, you might have an air compressor that you want to have a dashboard for, and you want to have 20 variables that you're collecting displayed in a number of different ways. we can build the dashboard for that one person, that one department, and that, again, there's no limits to the number of dashboards and widgets you can display. So we typically start by building the dashboard ourselves, and then we have the option for our clients to customize them. Because every project is unique, every client's requirements are unique, we can make them as simple or as complex as we want. So our dashboards are dynamic. Gone are the days of downloading data into CSV or Excel files, doing pivot tables and graphs, and having weird formulas, constantly kind of manually doing this. The point of this is we can be very dynamic. So for example, here at the top, there's a drop down here, and we can select the time window. So if I'm only interested in the last 24 hours, I can click that and all the data is updated to show the last 24 hours. If I'm looking at longer trends, I can do the last 7 days, and that data loads instantaneously. So that's pretty cool. And then some of our time series graphs, like these line or bar charts here, they have this little gray window here where I can further zoom in. So maybe I saw an interesting kind of peak here, and I want to kind of delve into that and what's going on here. I can move that around, and I have no problem zooming in without affecting the rest of the widgets on here. So that's pretty good. We can also do multi-device or dynamic dashboards. So it's not shown here, but maybe you have 20 identical sensors, maybe they're thermocouples around your facility, and you don't want to have 20 dashboards or a long kind of complicated dashboard setup. We can have a drop down here where you select the specific device or variable, and it shows it on a single graph, and we can overlay those. So again, as simple, as complex as we want. The other thing is we can show stuff on a map, for example. So this is great for clients that have multiple sites. We have one client that I believe is in 4 different provinces. They want to know their facility temperatures. They had no other way to doing that before. We're able to plot that on here, and then we can just click into specific sensors, and we can look at all these things that are running and visually display them. And we can change the colors, the icons, show specific variables or all the variables. So again, very dynamic, very intuitive. And if you've used Google Maps, you can use our dashboard. The other thing is we're going to go through these widgets next. There's a lot of them. We're just kind of scratch the surface. But the big thing to take away is these images or these widgets are dynamic. So I can just drag and drop, expand them as I want. As you can see, everything is very easy. We call this low code, no code, because at the end of the day, I want to be able to empower my clients to build their own dashboards and move things around. So as you see, obviously doing this in real time, but I can change things up as I go. So we'll go through each of these widgets, but also keep in mind that every single one of these widgets, we can customize the variables. So in this case, we can look at the different variables and the appearance and the scales and all that. We can do other things too. We can export the data specific to that variable just by clicking a button and downloading a CSV if we want to do that. We can delve in and explore the data on the back end. We can enlarge specific graphs. Maybe we're doing a presentation, we want to show that. We can share this. So this is a cool feature. Maybe you're working with a consultant or a colleague. They don't have access to the dashboard. We can just create a public link, copy that, put in our email, and all of a sudden they click that and they can see that live. We can also embed this widget or this dashboard. So maybe you have a intranet or a SharePoint, or maybe you have a TV in your break room and you want to embed that so that maybe you're empowering your employees to have that additional visibility. You can just take that, put it into an iframe, embed it somewhere, and you're good to go. So again, very kind of powerful. So we can do a number of things with our widgets. We can do device summaries. So for example, here, I'm showing specific important variables that I want to see in real time. And these are hyperlinked, so I can click that, go into the back end of the system, and delve into the data a bit more. I've already shown the map one. So again, fully customizable there. We can display it however we want and choose the exact variables and devices, and it's all kind of connected there. This is a pretty neat one that you see a lot of off-the-shelf systems don't have. Things like images, like simple things like maybe you have 3 or 4 similar pieces of equipment that, new employees or co-op students, they don't know the names or the serial numbers. We can just put contextual information like an image, and that way someone looking at this can identify the specific piece of equipment or the sensor they're talking about without having to kind of decode these complex names or serial numbers. This is a pretty straightforward one. Temperature, it's a temperature graph. We can code this in to be color coded. So maybe it's always black, but if it exceeds a certain temperature, it turns red, or maybe it's green if it's within two kind of ranges. So again, pretty straightforward, but temperature is used a lot in the facilities for obviously environmental controls and also operating temperatures for specific pieces of equipment. We can do metrics, so just display numbers. In this case, we're showing the humidity at Guelph. This is obviously real time. But if I wanted to take an average of the humidity over the last 24 hours, that's all I need to do. And I don't have to do any weird pivot tables or download the CSV. And I can save that. And now that is always going to be like that. And I can make multiple ones and have one for average today, average yesterday, average last week, that kind of stuff. So again, super powerful and very, very easy to navigate for our clients. We can have gauges like this. So this is runtime gauges. So we can take a metric like a amp logger or amperage from an amp logger. Say if it's over 5 amps, consider the machine on. Let's count those hours, and we can count them per day, per week, per month, per year, helping with our predictive or preventative maintenance, and just looking at, maybe this machine should only be running for 4 hours a day and it's ran for 10 or 12. That's an issue. And we can look at that and historically and in real time and action those specific changes that need to be made. We can do things like tank levels. A lot of facilities have tanks. If you're in a brewery, if you have silos, we can connect ultrasonic sensors and other type of sensors and show you that in real time. And that's really useful for a lot of different operations. Obviously, we have these kind of temporal or these line graphs here. So again, I can zoom out and play with the data, look at the trends, and again, I can do things like averages, that kind of stuff. And so I can do rolling averages. Again, very easy, very intuitive. I can isolate specific variables. So I might have a graph with 10 variables because they might all be related, but then I can isolate specific ones. So that's good. Same with the humidity bar chart here. Again, just a different way of showing the data, but fully customizable. And you don't get this with a lot of off-the-shelf systems. You're kind of often forced to use a specific visualization system, or you're limited. And that's not a good place to start. We want to be able to grow these dashboards as we deploy new sensors and get new ideas. And being limited to specific ways we look at the data or do statistics, it's just not a good way to kind of invest your time and money. So you want something that can grow with you and your system. We can do heat maps. These are one of my favorite ways of displaying data. You have days of the week on the left, and you have time from midnight to the following day. So again, we can look at kind of longer term trends, and again, we can look at averages, minimums, maximums, and we can highlight stuff, and we can even kind of isolate stuff. So maybe we're interested in certain variables that fall between this range. We can quite clearly see over the last week where they fell, and all this data is exportable if we want. We can look at daily totals. So in this case, we're taking water consumption from a water meter. We're looking at it daily. And we saw that on November 26th, that was likely a Sunday, that was low consumption. That's what we expected, but maybe Saturday was a little too high. Wonder why that is. Maybe we should look at that. Maybe they were working, maybe not. Then of course we can have more kind of conventional SCADA type visualization. So a lot of engineers prefer this. We have a full SCADA widget. We can customize it, and we can show your system in this format. A lot of people prefer that because that's what they're used to, kind of with older or existing kind of technology. And we can also even do camera feeds. So for example, here, most facilities have cameras either for security or sometimes for visibility for production or engineering purposes. Most modern cameras have a way for us to input that feed into your dashboard. So again, why flip between 4, 5, 6 different systems for water, natural gas, visibility? You can do it all in one. And that way, you can see, hey, my conveyor stopped and I see that on my camera. It's a great way to kind of visualize what's going on. Now on the back end here, I wanted to show you, this is what kind of the back end of the system looks like. So each one of our sensor collects dozens of different variables. And so we're even measuring things like battery levels and signals. And so those are the raw variables streaming in from the sensor. But we can do cool things like synthetic variables. So we can apply code and pretty advanced Python level code where we can take the data and manipulate it. So in this case, we've just kind of done a bit of kind of massaging, converting a 4 to 20 milliamp signal into a temperature for this purpose. But we can do a lot of different things and use kind of if statements and conditional logic. So we can take simple raw data, for example, amps on an amp meter or a CT clamp, and turn that into runtime hours, kilowatt hours, cost, GHG emissions. All these synthetic variables we can utilize from one raw variable. The other thing I wanted to quickly touch on is alerts. So of course, accessing the data is great for when you want to actively look at the data, but a lot of the time everyone's busy. They're just assuming things are working properly, and we don't want to have people always looking at the dashboard. So we can do alerts like this demo alert here, where in this case, if we say that this variable exceeds 25 degrees Celsius for 20 minutes, we're going to action something here. We're going to send an email. We're going to customize the subject, the message. Maybe we want to repeat this alert if the condition continues to be true, and get multiple alerts. And when it gets back to normal, we always also want that alert as well to say, hey, everything's fine, and this is it, and we can investigate that after. So that's pretty neat. But there's also other actions. We can send you a text message. We can make a voice call with a synthetic voice telling you exactly what's going on. Slack messages. So kind of the sky's the limit with what we want to do here. And of course, we can even have time windows. So maybe specific people want to receive alerts during their shift, but not after. You don't want to bother them maybe after hours with the text. We can code that in too. So quite handy for passively monitoring and acting on things that you may not want to kind of continuously stare at a dashboard. The other thing our clients love to have is automated alerts and reports. So in this case, this person wants a report at 7 a.m. every morning, and basically they want to open their email when they come in for their shift and have a nice PDF report that they can share with their team at the team meeting, that kind of stuff. So again, any data that we see, any widget that we see, we basically can convert that into an automated schedule report, and it'll show up in your or your team's inbox. And that way, you're really not even using the dashboard. You're relying on alerts and reports. And then if there's anything weird going on, then you're going into the dashboard. So overall, I think you'd probably agree that this is quite a powerful and customizable system. And this is just a very, very quick kind of live look at a dashboard. In this case, we're collecting temperatures on the floor and ceiling of this warehouse. We're looking at the temperature difference here. We're plotting that up in real time. We have some upper and lower limits that we've put in so that if it exceeds that, the person can figure out what's going on with their HVAC system. So again, we're seeing water main usage. We're doing a 7-day moving average, so we can trend their water use over time. We see their minute-by-minute flow rate, so we know these are water softener events. Yeah, these are other events, and in this case, we see a base flow actually. So we already know, the client's already aware. We've actually told them this weekend that they have a base flow, but this is exactly how we prevent excess water use. We look at this data and we say, hey, this is looking a little different. Your water signature is off. There's a baseline. We can action something. So again, air compressors, you name it, whatever kind of data we can throw on our dashboard, we can display it. So I'll kick it back to Dave here, but I hope that was a pretty good idea of what our system can do.
So yeah, that was great. Thanks, Tom, for showing exactly how the actual dashboard works. Now that you're kind of educated on that side, and you see how the hardware sensors provide the minute-by-minute data to feed that dashboard, this is the really exciting part of this presentation. This is where we're now taking that data, looking at that dashboard, and finding some really practical applications, which are providing the ROI to fuel these projects to begin with. So I'm going to take you through a series of about 8 case studies from specific facilities over the last 2 years. Like I mentioned at the beginning, we did a webinar a month ago. And since that month, we've been able to add 2 more case studies just because how rapid this stuff happens, how dynamic manufacturing is and how these flows of water and electricity, they're so hard to watch that once you get the visibility of it, you see how often this sort of stuff slips and how you can immediately react to it. So just last week, we found a great one I want to share with you. And I'm going to move through from some really straightforward, kind of catches into bigger sort of sustainability projects that have reduced overhead costs. We're going to start with water. We found that that's the most lucrative. It's the most overlooked. When people think ESG, being more efficient, immediately we get our blinders on. Okay, let's look at energy. Let's look at solar panels and all these great things. Kind of the hidden gem in all this is the water side. Water costs are going up 10% every year. It's always contained in pipes. And when you do have flows of water, your typical kitchen sink flows at about 8 to 10 liters a minute, just to put this in perspective. A given factory will have the equivalent of 50 end users, right? So for one maintenance manager or a team of 3 to constantly keep an eye on all those different end users, we've seen it's impossible. You need to employ this technology to give you this sort of visibility. And in Guelph, for example, or most of the GTA, Toronto, those sorts of areas, a 10 liter per minute baseline flow is about $15,000 to $20,000 a year that you're losing. And you either don't know it, which is usually the case, or once we spot it on that trending data, let's go out, tackle it, and eliminate it. So I'll start with that. Then we're going to move into some electrical examples. And then we're going to dive into some special projects and let you know that we're working on natural gas and a bunch of other stuff too. So here's a great project. It was at a pharmaceutical facility. We had our smart water sensor on, and you can see quite clearly there in July of 2022, water never dropped to zero. So, that's a month's worth. So there are some weekends in there where it typically should stop. We know that this production facility operated Monday to Friday with weekends off. So there should be no water use on the weekends, yet we're seeing 30 liters a minute all the time. So we took that data, we went into the facility and applied our experiences. I personally, went through and found the culprit. It was a failed solenoid valve. Solenoid valves are meant to provide water to systems. They're designed to fail open because you want water going to that system, even if it's at a loss to the company, because it needs to protect something. So we fixed that solenoid valve on a Friday in late July. You can see the exact minute when that was replaced. And here we are, we're down to zero. We're constantly monitoring their water now. We've put an alert in. So when that solenoid fails again, we'll be immediately alerted. And again, avoid that $45,000 overhead charge. The other interesting thing we found with this is, we found this herringbone structure. Talking to the team, we realized that was their irrigation of the lawns around their facility. That opened up a conversation with the landlord, who's paying for this. It's not just seeing large things on or off, but it's truly quantifying it, right? So we can now see, we can add up all those spikes. We added it up right down to the cent. It's costing them $8,000 a year to irrigate the land around their building. So now it's a real conversation. Is this something we want to invest in? Is it worth that amount of money? Moving on to the next case study. So this one seems simpler. It's just a ball valve that was left open. But the real power of this particular case study is we have been monitoring this plant for a while. And again, it was 0, 0, 0, no baseline flow. And then about 6 weeks ago, this turned on. So, the facility knew about it. They started looking around for it, couldn't actually identify it. So I went in one evening with this data, now knowing what's going on, went through the facility and found that it was a ball valve that was controlling the boiler blowdown. Which is a common culprit. And we can see exactly when I turned that valve off, went down to zero. This one was actually in Guelph. So with that cost of water was $50,000 a year. They had already spent about $5,000 to $7,000 on servicing this, let's call it a leak or a water loss. But we thought we were ahead for a little bit there, but then again, the data is now showing we have a 3 to 5 liter per minute baseline flow. So something to look at in the future and help them out with more. A similar situation here. So, big facility, lots of end users for needed equipment like cooling towers, boilers, etc. But in this case, it was just a leaking toilet in one of the employee washrooms. Similar situation though. We can clearly see their Monday, Tuesday, Wednesday, Thursday, Friday production, bit of sanitation on the weekend there. And you can see over here in October, baseline flow was 0. Yet something happened. It triggered an alert. It got us talking to the facility and said, hey, you know what? You now have a 7 liter per minute baseline flow in your particular region with your water billing. That's worth $15,000 a year. Let's get on it and eliminate it. Maintenance manager found the broken toilet, fixed it, and now we're ahead again. So really cool study there. And these just happened in the 2 weeks, like I mentioned, past 2 weeks. So that's on like particular losses of machines failing, which is obviously powerful and provides a lot of visibility and recouped cost to an operation. And it'll always happen. Water's dynamic, solenoids fail, toilets break, you want to know right away. But the other thing we do is start looking at long-term trends and start applying water reduction projects on a multi-scale level and over time. So with this particular facility, we're actually quite proud of this particular project in this graph. We've reduced their water use by 50%. Now there's a lot to unpack in this graph. There's fixed pipes, there's fixed valves, there's changing the way machines operate. This was actually supported by the local municipality as well with funding. So the ROIs on this particular project are, I think we're measuring it in weeks now, the amount they've spent on these sensors and our time to realize these savings. So not just a cost competitive thing, but a really fantastic ESG project, because as you can imagine, with every liter of water, there's embedded chemicals, there's embedded transportation, embedded carbon with the city. So a really nice project here that really summarizes kind of our longer term relationship with clients and how we get them to achieve their goals. So here I'll nail down more into granular level on a very specific piece of machinery. If you do run a boiler, they're just as energy hungry as air compressors. We can very quickly roll out systems that look at your boilers. Big users of water, obviously, natural gas and chemical. Sometimes you have overrun times. In this case, it was this common question we hear all the time. Should we be idling down or turning off our boiler when we're not needing to use it? Well, I've been in those meetings in boardrooms, and anecdotally people say, well, you know what, it's actually better to have it idle at a lower level so that we're ready for production, we can just ramp it up a bit. But we don't really have the numbers to make that case and say, well, you know what, doing that conventional practice is actually going to cost us $50,000 a year to idle it. What if we turn it off? What are we going to save? So that's the money side of things. We also need to consider what's the risk. If that boiler is not up and running Monday morning, is that production schedule at risk that day? So these are all the things we need to talk about, but you need the quantified data going into that discussion to really make an informed decision. In this particular case, they had the right boiler, the right scheduling. You can see on the left there, they were letting it idle, lots of water, lots of natural gas, lots of chemical loss. Now we're able to ramp it down and turn it off on weekends. And we've been able to repeat that. So huge savings there, and it's all tracked, which is exciting. Same but different. So let's transfer this opportunity over to a cooling tower. This kind of takes in elements of other case studies where it's a long-term project, but optimization of an entire cooling tower system. So again, behind this graph, there's a lot of interesting projects, changing the cycles of concentration, upgrading valves and meters, changing the way they filter the water in the cooling tower. But this is all owned by the environment team at this particular facility, and they take this to upper management and say, look what we did over the last 6 to 8 months to reduce the cost of operating this cooling tower. I think the real takeaway from this, you really have to study the graph, is we're moving on the left from June into September on the right. So those middle months, that's when the cooling tower is under a lot of load and has to provide a lot of cooling. You would typically see water levels increase or water consumption increase on a cooling tower. But we had so much traction there and so many cool projects that it was actually reducing it during the hotter months. So again, to zoom out, bigger picture, we're really excited about this graph next summer, because now we're going to be able to compare 2 years of data and truly see those longer trends over time. We can start layering stuff. So now we can take water, which we see here on the base graph, but then we can start layering on top of that other sensors we've installed. So this particular facility had an issue with their wastewater pH. So in the top left there, you can see the exact wastewater pit we're talking about. We put our pH sensor in there, again, minute by minute real time. So it's alerting the production staff and management to when they're over or under pH, because that results in some pretty significant fines. So they can avoid that on the one side. They can keep track of their baseline flows and their production sanitation water use. But now we can overlap these areas of data or data streams. So we can see that, during sanitation, obviously lots of water use, but what's happening with that pH level? So we can see how those two are interacting. We can share this graph with their consulting engineering company that's designing their wastewater pit. So now they can take this live data and create the best fit wastewater treatment system with real-time live data. Again, on a very granular level, this is with a heat exchanger. So, if you have a heat exchanger that is not really performing up to snuff, we actually put in multiple sensors on this. So we've got flow and temperature in and out, oil and water. So this engineering team, dynamic dashboard, every day they're checking into this. We've had this particular press heat exchanger being a real issue, not providing the cooling it should be for the last 3 months. What's actually happening inside that heat exchanger? Our data clearly showed them after about 3 weeks, they took it out of commission, cleaned it, got it back up and running, flow increased, heating capacity and cooling increased. So it gives you very specific project data that you can use to optimize particular systems. Onto the energy side now, it's not just all about water, even though there's some quick wins there. People want to understand what their electrical billing is. They want to feed that into their ESG goals. So here we have a compressor. Unfortunately, a lot of compressors we see are running all the time unnecessarily or at PSIs way too higher than they're needed. So this is actually a double case study. We can see on the left here, this particular air compressor, and you may be able to relate to this, it's running in a back room where no one ever goes, and it was full out all the time, every minute of every day, even over Christmas and the New Year when no one was there, consuming the equivalent of about 30 households of electricity. This is just a 50 horsepower air compressor. We go into facilities with 300 horsepower air compressors, and right now we're starting to see just how much more amperage draw and cost that is, and a lot of times running unnecessarily. So again, you may have shifted your production production output and timing. So you may have been 24/7, 7 days a week, but unfortunately, maybe you've had to dial back a bit. Are your machines still running with a 24/7 production shift? If they are, you're losing even more money. So in this particular case, we just went over low cost, no cost, readjusted the set points of that air compressor. Now we're running it when we don't need to. The next step we did, and again, this is where Quantify has that 2 different stages of our projects. It's visualizing the data, but then actually acting on it and working with the clients to implement it. We went out in the field and started talking to the guys out in the production floor. What PSI do you need to do your job? The end result was about 90 to 100. We went back, this machine was chasing constantly 124 PSI. So we slowly dialed it back 2 or 3 PSI every week. And now not only is it using a lot less energy when it shouldn't be running, it's using less energy when it needs to be running. The other exciting thing about this particular case study is we're able to put these KPIs or metrics that Tom was talking about very specific to that team. So they wanted to know, how many run hours have we saved by these new changes? What's the equivalent of kilowatt hours we've saved? Obviously, what's the dollar ratio? So within 4 months, we saved them $14,000 in electrical costs with a no-cost solution of changing those set points. That right there is your ROI. That's what pays for the projects quite rapidly. The other cool thing, of course, is your GHG emissions. So when Tom was showing those algorithms and how we do our calculations with synthetic variables, that you kind of saw that math there, that's what we're applying. So this is right down to the gram of CO2 that you're saving. And this is the sort of stuff that the PR teams and the ESG teams really want to use because it's real. It's not estimated or assumed GHGs, scope 1, scope 2, scope 3. That's a lot of work. This is granular. This is exactly what's happening. Just to prove the power of this particular opportunity, we went down the street to the next door neighbor, their factory, told them about this. We deployed amp loggers on their air compressor, basically repeated the exact same project. And they're about $10,000 ahead because of that win. So it just shows how deployable this is. Those are kind of all on the cost saving sides. This case study, again, it's kind of a double case study. The first point is quality assurance. So I was at a facility installing something else. I happened to be in a meeting with the quality assurance manager and they said, hey, we've got these thermolators. I need to see the temperature of them because right now they can only trend 3 hours of data. But my clients, our customers are saying, we had an issue 2 weeks ago and we think it's temperature related when you were producing this particular product. Well, they couldn't trend that. They couldn't prove that data. So we hooked up into that machine, we were able to, within 2 hours, get that data onto the dashboard we had already set up for them, made a specific dashboard for this particular line, and now they have constantly trending data of that temperature set point. So if their customers ever come back and have an issue with the way that product was produced, they can clearly and confidently present this data and say, no, we're at the exact right temperature specs during your production run. So that's the quality side, but also just clearly shows how rapidly this deployable this technology is and how we can integrate it into your existing machines. The last one I want to share with you, because we are getting close to time, is what we kind of call our special projects. So we recognize that, water, natural gas, electricity are, pervasive. They're at every facility we go to. But you may have something that you've had for the last 5 or 10 years, and you're thinking, well, how much is it actually costing me to run this? Or what is the temperature set point, and how is that varying throughout a production shift? These are two interesting projects we put together with one of our favorite clients. One was a level sensor in a rail car. They wanted to know what the level of the tank level was. The other one was they had a multi-channel thermal probe. And prior to building this unit for them, they were manually writing down the temperatures. Now it's constantly trended. The guy out in the field using this never has to pick up a pen again, and data won't be lost. And it's real time. There's no fudging of numbers or anything. It's all digitally recorded. So we do like doing these fun projects as well, if you think you might have one in the back of your mind. And with that, I'll lead into this. We're hardware agnostic. We're integrators of industrial IoT. So we want to be able to tap into the things that you want to see. We have an interesting electrical conductivity project now that, alerts a team if their storm sewer goes too high. We have obviously that pH one. If you have ponds or other sort of water areas that you need to know DO or pH, temperature, air quality within facilities, you can actually use this as a bit of a hack too for security. If you have a door disconnect or lighting levels, I'm just going to leave that there for a little bit, get the gears turning in your head if there's something that you want visibility on. So with that, I will end. I really want to spend the last 10 or 15 minutes to have a conversation with everyone, understand where they're coming from, see if this answered any of your pressing questions. And lastly, just to thank you. We're pretty excited of what we've created, and we want to share this with everyone and let everyone know that industrial IoT is here, and it's really going to change the way you produce. So thank you again.
Thanks, everyone. Thanks, Dave. That was great. Yeah, so we have about, let's call it 10 minutes for questions. So I see we do already have one of our attendees pose a question here, and a few others kind of in the queue. So we'll kind of go through them, and at the end, I'll just remind everyone, use your Q&A feature on your Zoom or your chat box. Let us know those questions, but if you want to kind of talk one-to-one, feel free to reach out, book a meeting through our Calendly, and we can set up that quick meeting. So we have one question here, and we get this one often, and it's related to security. So this person asks, how do you prevent a threat actor from penetrating the IoT network and taking control of the data or a machine under IoT supervision? That's a great question, and there's a good joke in there. The S in IoT stands for security. This is an issue that we are obviously facing with any internet connected device, right? What kind of options do we have to prevent a threat actor from attacking that hardware or getting rid of the data? So I'll kind of start at the source, and we'll kind of go from the hardware to the cloud. So we use a base station, which is basically a custom computer with a bunch of sensors on it. That is not connected at all in any way to the client's network. That's running on its own LTE hotspot through a router, completely separate and managed by us. So I think Dave mentioned this, but teams love us when we're kind of scoping out or proposing or getting ready to integrate a project. Typically, they'll bring their IT guy in, and he'll say, what do you need from me? He'll say nothing. We're completely independent. And then he leaves the room happy, and he doesn't have to do anything. So there is no potential, if there is a vector or way to get into our system, there's really no potential for us to kind of that to flow into your network. The other thing is most of our sensors are passive, right? We're not controlling things. We're not really a controls company. So we're reading data. And typically, all of our sensors are one way. The sensors themselves are not connected to the internet. They're using a 900 megahertz spectrum radio signal to communicate passively to the ether, if you will, and then our antenna on our edge computer grabs that information and then puts it up to the cloud. And most of the time, actually, we actually have to be present, or someone has to be present physically at the sensor to configure and calibrate it, right? So we can do some on the fly, kind of over the air calibration for some specific sensors, but generally speaking, you have to be there, press a button, and configure that sensor. Of course, there is always potential for threat actors or someone to kind of access that. So we obviously things like strong passwords, multi-factor authentication, encryption. So all of that data as it's streaming in is encrypted. You need to have the encryption key to read it, and then it's encrypted going up into the cloud. And then, of course, on their dashboard side, we use kind of conventional data centers, and our software provider ensures that if people want to use multi-factor authentication, we can. And let's be honest, at the end of the day, if your data were truly were to leak, it's not the biggest concern. Obviously, it is a data breach, but they're not controlling anything. Typically, they're just going to see your kind of water use and consumption. So not the worst case scenario, but still, we take security very seriously. And so I hope that answers your question. But to date, we have had no issues. And using a combination of encryption, multi-factor authentication, independent networks, and read-only devices pretty much ensures that there's very little risk. Thanks for that question. We have another question that came in here. Can the portal views and data pulled be altered by the client on the fly, or do clients submit a request? So I think the question is kind of related to the visualization of the dashboards and customization. So we kind of have two options. Typically, our clients hire us because they don't have capacity or the expertise even to kind of drag widgets around. So generally, we'll have support tickets come in, and you can just click, enter a support ticket, email us, pick up a phone. We'll get that sorted for you in a few hours. That's not an issue, but we can give permissions and have different users have different permissions in your organization to allow specific changes. So maybe you want to be able to create your own dashboards but not change existing ones. We can give you that permission. So we like to empower our clients with every deployment. We have a training and onboarding session at any time. We have ongoing managed customization kind of programs so that we meet with the client monthly and say, what do you think of this data? How are we, using it? How are we displaying it? We can kind of sort that all out. But yeah, absolutely, everything is fully customizable. As far as altering the data on the back end, we can again have permissions to kind of remove or delete stuff, but typically that data is not altered, right? You don't want that data being altered because then you have the potential that someone's just going to fudge the numbers, and we just don't want that. But we have those permissions if we truly want. But most of our clients rely on us to customize initially and then ongoing customization. Hope that answers your question. Dave, any other questions that you see? I have a few here that I'd like to cover, but I'll kind of hand it off to you.
No, I'd say keep going. If you got them in front of you, and we'll throw them back and forth, or if you want to answer them.
Sure. Yeah. We have a question here about integration of IoT sensors and how do they, how does our tech integrate with existing devices? That thermalator example that Dave talked about in the QA slide was a perfect example of a piece of equipment that someone already had, was already running and configured to kind of do whatever it needed to do for the process temperature, but it had a 4 to 20 milliamp output, and we can tap into that with our 4 to 20 milliamp receiver. So all we need to do is do a single or a 2-point calibration on the low and high end, and translate that milliamps to temperature and then display that. So the nice thing is, a lot of people have like Keonce's non-invasive ultrasonic flow meters already in their system that just locally displays a flow rate, or you have to use a CSV kind of data dump to pull that data. Well, we can integrate into that existing Keonce. You already have the sensor. We just have to, make the sensor work with our hardware and our edge computer and get it online. That's our job. That's what we provide. And you don't have to dish out additional money for specific sensors. We can do Modbus integration. You might have a PLC. You might have an existing SCADA system. We can read that information as well. or we can even do APIs, right? So a lot of the time our clients have maybe went down the IoT path. Maybe they have a kind of proprietary water sensor, but we can't show electrical data on there. We'll be able to, if that service has an API, pull in that data via an API, display it on our dashboard, and have everything centralized. So
Yeah,
hope
and just
that.
to add to that, like when we're in facilities and we're looking at existing equipment, even things like 30-year-old boilers, they'll have 4 to 20 output, sometimes Modbus, sometimes Pulse. They were put there for a reason. You would have had old SCADA systems tapping into them. But with this newer technology now, it's within a few hours, we can have systems in place and pulling that data that in some cases the client didn't even know existed that could be done. So all of that is just to assure people that this doesn't have to be a capital intensive upfront cost for a project. You don't have to go out and buy a whole new suite of sensors. You may have things in place that, again, with that thermolator example or boilers we've looked at, they just don't have the capacity to trend that data, or you're looking at a very old, dated, and stationary screen. And we kind of alluded to it earlier. One thing to remember, and where it's really practical, is plant managers or production managers on the floor can be looking at these trends of the device in front of them on a laptop, a tablet, or even their phone. So it really brings that data alive and practically puts it in your hands so you can start manipulating that machine.
Thanks, Dave. We're getting to our 1 hour mark. I have two quick questions to kind of answer that are quite common here. One is related to battery life and maintenance. What is the average battery life of most of our kind of wireless sensors, and how is their maintenance managed? The answer is the hardware that we typically like to source. They come with a 5-year warranty. They're made actually in the US, not overseas, which is fantastic. We can customize the sensors as well to our needs. They run off AA lithium batteries, either 2, 4, or 6 of them, depending on the sensor. And again, it depends on how frequent you're gathering the data, but at a 5-minute interval, they can last 5 to 10 years, right? So at some point, you're getting to the edge case of how when the batteries start to expire. But if it does kind of run out of juice, we'll get an alert way before it does. We'll action that, send you new batteries. We can throw it in, you can throw it in. It's just a few screws. It's very simple, easy to maintain. And if there's any issues, that's why we most of our services are kind of on a kind of monthly retainer, if you will, managed retainer. Our clients just want to worry about production, worry about operations. They make sure that everything is online, everything's connected, everything's updated, everything's working properly. And if there's an issue and it's our issue, there's no charges. We make sure that your data is continuing to run and look great. So that's another one, and that's part of the support and training. All of our onboarding comes with dedicated either on-site or remote training. And typically, I just want to kind of put this out there. What a project looks like, we'll scope out the information. We'll talk to the different people, different departments, find out what they need, order the hardware, configure it, set up everything off-site. We just did a deployment yesterday. Took a few hours to get a few sensors up and running. By the time Dave left, the client had full access to the dashboard. All the widgets were built. The data started streaming in real time. And now we're holding a training session in a few days with them to kind of empower them to use that data more and to understand all the features, kind of what we did today, but in a lot more depth. So, that's the kind of support we offer. When we leave, everything is up and running. It's clamp on, non-invasive. We're not running wires and conduit for weeks and months and paying for that. We pop in and you don't even notice we're there, and then we're just there in the background helping.
And just to add to that, Tom, like the packages we sell, we always mandate monthly meetings. The reason we do that is we both came out of an industry where good data was being produced, interesting projects were being highlighted, but there was no action on them. With the technology we have now, with the dashboard we have, the live data, it's clearly showing opportunities. The worst case scenario is nothing's done, nothing's implemented. So we found that just booking in monthly meetings or more with our clients, where we sit down for half an hour, sometimes they're virtual 1 month, other times we'll be there on site. We're just going to look at the data together for half an hour and ask, one plant manager, why did the electrical spike on that one machine last week? Oh, we had to do this extra clean cycle, or I don't know. Okay, let's look into that. Let's implement it. So that's the other major support that Quantify offers. It's not just the trending data in the dashboard, it's the monthly support. So you're able to achieve those ESG goals, those profitability goals. So your plant is actually running more efficient because you get the ROI back from that. You know, you're going to be paying less utilities, you're going to be maintaining those equipment much less, which is dollars in your pocket. So it serves everyone.
Awesome. Thanks, Dave. Well, I think we're a little over our hour mark here, so I think there's still a few more other questions, but we'll just follow up with people after. On behalf of Quantify Environmental, thank you so much for attending our webinar. Hope you enjoyed it. We will be releasing this on YouTube in the coming days, and we'll send everyone a link. If you want to know more, check our website out, quantifyenv.com. You can shoot us an email or meet with us by just going quantifyenv.com/meet. You can see our live calendar on Calendly, book a meeting with us. We'll come out, we'll chat with you on site, and we'll kind of show off our solutions, and we can kind of talk about next steps. But hope that everyone enjoyed it, and thanks so much for joining. Thanks.
Thanks, everyone. Bye now.